fundamental theorems in vector calculus, and one of them is Green's theorem. Green's theorem was invented by George Green, an 18th century British mathematical physicist. George Green had privately published an essay on the application of mathematical analysis to the theories of electricity and magnetism in 1828. As stated in Green's theorem, let delta R, which is a simple closed curve that is piecewise smooth and positively oriented. Meanwhile, let R be the region bounded in delta R, and let the continuous function with continuous first partial derivatives in R be f1 and f2. And then the equation in the Green's theorem will be as in the figure below. The theorem is only applicable if the curve delta R is positively oriented, piecewise smooth, and simple plane curve. Other than that, the f function, which is equal to f1 plus f2, is a vector field with f1 and f2 defined and have continuous partial derivative in an open region containing R. Next, this is our case study. A large rock had been thrown into the lake, causing the water to produce waves and ripples that go outward. As a result of the waves and ripples, an ellipse-shaped border around the water is formed. Other than that, as the rock sank into the lake, the calm water would follow the rock in the same direction. For the first question 1, what is the area of the ellipse-shaped border? X squared over 64 plus y squared over 36 equal to 1 caused by the waves and ripples.
For the manual solution of the questions 1, the equation of the ellipse given in the questions is x squared over 64 plus y squared over 16 equal to 1, and the a is 8 and the b is 4. And after we got the value of a and b, we substitute both of them into the position vector equations, and we got the x and y, and we differentiate both of them. And last but not least, we use the third form of the area of the shaded region in the Green's theorem, and we integrate the answer, and finally we got the final value, which is 32 pi. For the maple solution, first we need to define the a and the b. The a is 8 and the b is 4, and the second step is we need to define the x and also the y. Third step is we need to define the ellipse, the color, the thickness, the scaling, and also the labels to make the shape of the ellipse appear in the maple. And also, fourth step is we need to define the dx and dy. So the output is dx equal to negative 8 sin t and dy is 4 cos t. And last but not least, we need to define the area. So the final answer is 32 pi.
Based on the calculation of the area of the ellipse-shaped border can be influenced by the size of the rock, the speed of the rock being thrown, and the waves and ripples produced by these factors, meaning that the larger the size of the rock, the higher the speed of the rock being thrown, and the greater the waves and ripples produced, the greater the area of the ellipse-shaped border. For question 2, what is the work done by the force field F equal to 6 times ax plus yi plus xy squared j along the curve C formed by the parabola y equal to 1 over 2x squared and the line y equal to 3x, which is the movement of the water following the rock.
Given vector field and equation of parabola and the line, first rewrite the vector field, then find the intersection between parabola and the line. After that, find the differentiation of p onto y, and we got 6, and find differentiation q onto x, and we got y squared. And fourthly, substitute into the Green's theorem. Lastly, we use type 1 to do the integration, and the final answer we got is 1141.71. For maple solution, first define the vector field and set y lower and y upper. Then find the intersection using this command. After that, define the equation for parabola and line and range for the x. Then use the plot command to plot the graph. After that, define equation for p and q, then give the command to differentiate p onto y and q onto x. After that, use integrand command to solve q onto x minus p onto y. And lastly, use the integrate command to solve the equation, and we got 7,992 over 7 equal to 1,141.71.
Based on the calculations, we get a positive value for the work done, which is 1141.71426, meaning that the energy is being transferred from the force field to the particle, which is the water, and it causes the kinetic energy of the particle to increase.